Welcome back to my channel. So for today's lesson or tutorial, we want to determine the ionic charge of the first 20 elements. Now most people have issues with this topic, so I'm going to treat it very nice and an easy way for you to understand. How do you know, okay, what's the charge on oxygen? What's the charge on oxygen? You know it's 2 minus. What's the charge on chlorine? Minus 1. What's the charge on hydrogen? Plus 1. What's the charge for helium? 0. Now, how do you know all this? How do you know it? Some people have issues with this aspect, so I'm going to be covering that in the next few minutes. So let's start. So we want to determine the ionic charge or charge for the first 20 elements. For the first 20 elements. So we want to determine the ionic charge for the first 20 elements. Alright, let's go. Now, ideally I should draw a table, but before I draw a table, let's do something. Okay, let me draw the table first. So I'm going to put elements. I'm going to put the charge. So let's reset our first 20 element. I believe we all know it by now. The first 20 elements, you have what? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. The next one, you have fluorine, you have neon. I'm going to come here again. Elements and charge. Neon. Then we continue with sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and what? Calcium. So these are the first 20 elements. Little better boys, come near Olu for new national magazine. All CD people should clear away color star. Alright, that is the first 20 elements. Now we want to determine the charge. Now, for us to determine the charge, one thing we just need to take note of is what we refer to as valence electrons. The key thing we need to note here to determine the ionic charge for the first 20 elements is what we refer to as what? The valence electrons. Now this, I'm only determining for the first 20 elements, but the pattern I'm going to be using here is what you're also going to continue with. So if you want to determine those of other elements, no problem, just make use of this idea. So now we're going to make use of a key term here which we refer to as what? Valence electrons. So what are valence electrons? These are electrons in the what? Outermost shell. These are electrons in the these are electrons in the outermost shell. So we said valence electrons, these are electrons in the outermost shell. So that's the basic definition for a valence electron. Say I draw a shell like this, and this electron contains 1, 2, 3. How is it together? Let's assume that okay, we have the inner one. The inner one can only take 2 shells, which is the K shell, right? This is the outermost shell. This is the inner shell. This is the what? Outermost shell. So the outermost shell, how many electrons does it contain? It contains 3. Are we following? What if I only drew the inner shell, which is the K shell, and I put 1? That means the valence electron here is going to be what? 1. What if it is 2 electrons? It will be what? 2. So valence electron simply means the electrons in the what? Outermost shell. Now let's start. Let's draw hydrogen. Let's draw our shells for everything. Now, in filling hydrogen and helium takes a shell referred to as the K shell that can only hold maximum of 2 electrons. Are we together? Now this shell, now this K shell can only take 2 electrons. Are we together? That means in filling hydrogen now, if you want to draw for hydrogen, you know hydrogen starts with what? Atomic number 1. That means it has 1 electron without no charge. You can see that all these elements, these are their elements itself. We want to derive their respective charge. Are we together? So now this is hydrogen, right? It has one electron, one proton, one electron without no charge. That means hydrogen is going to have what? One electron in its outermost shell. If this element does not have any charge with them, their proton will be equal to what? Electron. That means if this hydrogen has one proton, it will be equal to what? One electron. So that means this is hydrogen. Now we filled hydrogen already. So hydrogen we have a charge of. Now before I put the charge now let's do some key. We have some keys that I want to be using. One, if the element is completely filled up, if the element is completely filled up, that particular element, has a charge, has no charge, that is, it is 0. 2, if an element has 1 to 3 electrons in its outermost shell, it takes positive X, where X is number of valence electrons. The third key, if an element has 4 electrons in its outermost shell, it can take positive X or X minus what? It. All together. Where X, we have already defined that X is the number of what? Valence electrons. We've defined this here. Then the fourth key, these are the keys to determine your charge, ionic charge, or the charge of the respective element. Now for the fourth key, okay, then if an element has 5 to 7 electrons, it takes X minus 8. This one can take positive X or X minus 8, and this takes what? Positive what? X, and this is 0. So these are the key terms we need in deriving our respective what? Charges for the what? Element. Alright. Now let's start. Now I said if an element is completely filled up, that element has no charge. That means the charge is 0. So some elements, when we draw the structure and the electrons, the shell seems to be completely filled up, you already know that automatically that element has a charge of what? 0. Are we together? So let's start with hydrogen. I said this is hydrogen. Hydrogen and helium can only be contained in K shell. The K shell can only take maximum of what? 2 electrons. This can take a maximum of what? 2 electrons. Now all subsequent shells that we'll be drawing now will be taking 8 electrons. Are we together? All subsequent shells will be drawing will take a maximum of 8 electrons. The first inner shell will be taking can only take a maximum of what? 2 electrons. So now let's fill for hydrogen. Hydrogen has 1 proton. That means it will have what? 1 electron. Now that means hydrogen has a valence electron of what? Of 1, right? Okay, it has a valence electron of 1. That's correct. Now we already said that if it has 1 to 3 electrons in the outermost shell, it takes positive what? X, where X is number of valence electrons. So this will be what? Positive 1. For helium, let's do for helium. Helium is atomic number 2, proton number 2. That means that's 2 protons, and therefore it will have what? 2 electrons. Now one would say it should be positive 2 with this rule, right? But what did we say? We said this inner shell, this K shell, and it can only take a maximum of 2 electrons. And if we said that if the element is completely filled up, that element has no what? Charge. If the element is completely filled up, that element has no what? Charge. So because helium is completely filled up, it's just going to have a charge of what? 0. Now let's continue. We said subsequent shells will be taking what? 8 electrons. Now let's draw the next shell. This is the next shell. Are you following? All right. Now this has taken 2. Abi now. So what will the next one take? This is our L shell. Are we together? So the next element here we have is lithium, and lithium is atomic number 3. So if we've done 2, the outermost electron is what? It's going to be 1. Are we together? So it still follows this conversion of positive X. This will be positive 1. Let's draw for beryllium. Beryllium is atomic number 4, Abi. We've done 2, 1. Let's add one more here. So what's the outermost electron? The outermost electron is what? 2. That will be positive 2. Draw for boron. Boron, we have 3 electrons in the outermost shell. Let's add it up. 1, 2, 3, 4, 5. That's boron. But boron has an outermost electron of what? 3. That means that's a valence electron of 3. So that will be positive 3. Now let's do for carbon. Carbon will be what? 6. 1, 2, 3, 4, 5, 6. That means carbon has a valence electron of what? 4. But what did we say? We said if an element has 4 electrons in the outermost shell, it can take positive X or what? X minus S. So we are going to first say for carbon, it can be positive 4 slash. You can also say it can take what? X minus what? 8. Where that would now be what? 4 minus 8, which is what? Minus 4. Let's do for the next element. What is the next element? Nitrogen. Nitrogen is what? 7. So we have to add one more. Are we together? So once you add one more, how many valence electrons do you have? 1, 2, 3, 4, 5. Let me use a blue pen here so that we can see some things. You can see this is 1, 2, 3, 4, 5. That means it has what? 5 valence electrons, right? And we said if the element has 5 to 7 electrons, it takes X minus 8. So that will become 5 minus 8, which is what? Minus 3. Let's do for oxygen. By the time we do oxygen, add one more here. Oxygen, we have 6 electrons in what? Outermost shell. That is 1, 2, 3, 4, 5, 6. So that will be what? 6 minus 8, which will be what? Minus 2. You can see it's following a pattern, or you see it's following a pattern now. Now let's do for fluorine. Fluorine, we take one more electron here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why fluorine is 9. But how many valence electrons do we have? 1, 2, 3, 4, 5, 6, 7. That will be 7 minus 8, which is what? Minus 1. Now let's do for neon. Neon will be complete, have you now? That's 8. Are you following? That's 8. Now, should you put positive 8 here? No. This neon, the outermost shell is what? Complete. Because I tell you, this can only take a maximum of what? 8 electrons. And since it has been completely filled up, the charge is just going to be what? 0. It's as simple as that. Now, you do the same thing for sodium. Now, let's draw sodium. I'll leave some ones for you to do as classwork or something. So, let's do for sodium. The first shell, we take 2. The next subsequent shell, we take 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, this is 10, Abi. Now, it's Oshikoyoko. It still remains 1 for sodium. This is 12, this is 13, this is 14, 15, 16, 17, 18, 19, 20. So, sodium still remains 1 more electron that we need to fill. So, I told you that the next subsequent shell, you make it 8 again. So this is what? Sodium. That means sodium has what? A valence electron of what? 1. So what are we going to say? Plus 1. Magnesium core, that's 12 plus 2. Are you following? Aluminium, that's 3. Positive 3. Are you seeing the trend? Silicon, that's 4 valence electron. That will now be what? Positive 4 or what? Negative 4. If I continue, minus 3, minus 2, minus 1, 0, positive 1. Positive 2. So this is just the trend already. So we can, let me just confirm now. Let's just confirm something. Let's do for potassium and calcium. So if you want to do for potassium and calcium, how are we going to do it? First shell we take 2. Next shell we take 8. That's 1, 2, 3, 4, 5, 6, 7, 8. That's 10, Abi. Next shell we take how many? 8 again. That will be 1, 2, 3, 4, 5, 6, 7, 8. That's 2 plus 8, 10. 10 plus 8, 18. Are you following? That's 18, Abi now. So the next shell we take how many? 8. So let's count. 1, 2. 2 plus 8, 10. 10 plus 8, 18. That is why argon is 0. It is completely filled up. Then the next shell can take 8, Abi, but we're going to put 1 here. That is for potassium. That's 19. That's positive 1. And for calcium, positive what? 2. So this is everything you need to know in determining the charge